All right, so in this video, we're going to dive into some of the examples on the notes page. Be sure to check out the 4 different cases and a walk through the ambiguous case in the previous video if you've not done so already. So in this first example, we want to find the number of possible triangles in triangle ABC and then given all this information here. Well, what I like to do first is I just like to draw a triangle. It really doesn't matter. I don't really care about it being to scale. You can spend a lot of time thinking about the configurations, but at the end of the day, I just need a picture to put some information on. So AC is 7 centimeters. AB is 11 centimeters. Angle B is 25 degrees. So we have to figure out how many different triangles can I make with this angle side-side configuration. So let's go to the law of sines to help me out with this. Really, the angle that's in question here is going to be this side, there's angle C. So the sine of C over its opposite side, 11, is going to equal the sine of 25 over its opposite side, 7. If I solve for the sine of C, I get 11 sine of 25 over 7. And if I punch that into my calculator, I get the sine of C is going to equal 0.664, blah, 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 blah. I take the inverse sine of that decimal. That should give me angle C, and angle C comes out to be 41.6 degrees. So this angle could be 41.6 degrees according to the law of sines. So that guarantees I already have one way of making this triangle. Now I just need to check if there's a second way. So let's do that by checking a second triangle check. And in order to have a second triangle, I'm basically using this 41.6 acute angle as my reference angle for the obtuse angle with the same sine. So I'm going to take 180 degrees and subtract 41.6 degrees, and that should come out with C could also be 138.4 degrees. So let's just check. If this angle could be 138.4 degrees as well, it'll have the same sign. The sign of this is the same as the sign of this, so it still would fit the law of sines. Now I just need to check, with this angle that I already have, am I still under my 180 degree limit? If I add my other degree, or my other angle to this possible angle, I get 163.4, which is less than 180, which means there are two possible triangles. So in summary, because they all worked out, this scenario and this scenario, there are two possible triangles. So there you go. Second example, very similar to the first, and we're going to start once again by just drawing a diagram. So I've got KLM, triangle KLM. Let's call that K, let's call that L, let's call that M. Again, it doesn't really matter. I'm just picking arbitrary points. I'm putting the information down. K is 56 degrees. LM is 16.8, and KM is 13.5, and these are meters. And so let's find the number of possible triangles. So once again, we're going to go to the law of sines. And I'm interested in this angle L. You know, a good question might be, well, how do we know which angle? Do I choose angle M or do I choose angle L as like the unknown angle? And really, it's going to be the one that we have opposite information for. If we're using the law of sines, hopefully you can see that I can't use this angle M because I've got no side that's opposite of that angle. So as far as which angle you're using, it's whatever is opposite of some information that's there. So the sine of L over the side 13.5 should equal the sine of 56 over 16.8. If we solve for the sine of L, we come out with 13.5 times the sine of 56 all over 16.8. And let's see, if I take that whole thing, I'm just going to punch it all in my calculator in one big step. The inverse sine of 13.5 sine of 56 all over 16.8. If I punch all that into my calculator, that's angle L. And angle L comes out to be, what do I have here, 41.8 degrees. So this acute angle is one possible configuration that makes this triangle work. So I know that I have one triangle. Now I need to do my second triangle, check. So let's do that. The second triangle, check. I'd have to check what my supplementary angle is. 180 minus 41.8 is my possible other angle. So L could equal 100, what do I got here? 138.2 degrees. That has the same sign as my acute angle. Now we just need to check. If I add my given information, 56 degrees, hopefully you can see that, I'm not even going to do the math. Whatever this is definitely over 180 degrees. So what does that mean? That concludes that this angle does not work, and I only have one possible triangle. Since I was able to use the law of sines to get one angle, and checking its supplement yielded a higher sum of angles greater than 180, that means there can only be one triangle in this example. So why don't you try this next one on your own? Again, draw a triangle, see if you can't work out the information for how many possible triangles there are. Or this should say possible triangles. And when you're ready, you can resume the video and check your answers. All right, so this is what I was able to work out for this you try video. There are two possible triangles. Go ahead and check my work and see if it makes sense to you. And when you're ready, I have another you try problem that is going to involve a little bit of creative thinking here, but I want you to find the measure of angle ABC, that's this one, and the length of BD, that's this one. So go ahead and pause the video, give this problem a shot, and resume when you're ready to see the answer. All right, so what I'm coming out with here is that the angle ABC is 66 degrees and the length BD is 4.55. You need a little bit of a tip as how I got here. Really, once I find this angle, it is the supplement to this 78 degrees. That's 102 degrees. And once I have that 102 degree angle, I'm given this angle of 12. So that makes this angle here 66 degrees. And now I have all the pieces that I need for the law of sines. So I can use this angle on opposite side, and then I can use this angle and this opposite side to figure out this 4.55 centimeters. So hopefully that was helpful. With the ambiguous case, the big wrap up or the big thing to keep in mind is you really have to go through all the possible outcomes in order to find how many triangles you can make if you're given just a side-side angle configuration. These are kind of tricky.